Yeah, welcome to this. This is Davika Academy, and we are looking at the characteristic and the meaning of polynomials. So this is Davika Academy. Kindly subscribe, share also with your friends if you have not yet shared with them. Now we'll start with this definition. Let this be a linear transformation. The characteristic polynomial for t is px, given by the determinant of xi minus I. So that, actually this should be t, because we are having the polynomial px, and we get the determinant of xi, whereby I is the identity matrix minus t the transformation. So that will give you the characteristic polynomial. Similarly, if you are talking about a matrix, and of course this matrix should be a square matrix, then its characteristic polynomial will be given by px being equal to determinant of xi minus a. The a is the square matrix. So the eigenvalues of this square matrix n by n are the roots of the characteristic polynomial. So if you work out for the roots, you are basically going to get the eigenvalues. Remember, the eigenvalues are the one we are defining as lambdas in our previous cases. So if you have not checked also for these cases, kindly tell us back, and you'll be able to see some of the examples that you worked on about the eigenvalues. Okay, let's look at an example. So we are having a hair here, which is a square matrix, and we want to find its characteristic polynomial. So by our definition, the characteristic polynomial will be given by px being the determinant of xi minus a. So this means that this matrix xi is basically the matrix x by the identity. Remember, this also depends on the kind of square matrix that we are having. So for example, in our case here, it is a 3 by 3 matrix. Therefore, we have an identity which is also 3 by 3. So if you multiply by x, you are going to find that across the main diagonal we are having x. So we are having x 0 0 0 x 0 0 0 x. So that's now the matrix we are calling xi. Then if you take away or you subtract our a from it, then you're definitely going to get this kind of matrix. And remember, this symbol stands for determinant, so we are actually saying this polynomial is actually the determinant of this difference. So that with this, now we can solve the solution for this polynomial, and by just solving the determinant of this matrix from our previous tutorial, I looked at how we can get determinant of a matrix quickly. We did something like this, so we did that one. Okay, so we are saying if you multiply the main diagonal, that's a positive, next positive, then minor, negative, negative, then negative. I worked on this trick last time, so you can look at the previous tutorial and you'll be able to see it. Okay, so the solution for this will be inevitably become this, and this is now what we are calling characteristic polynomial for this matrix. So remember, if you have not yet subscribed to this channel, kindly make sure you subscribe so that every time I post anything here, you are the first one to get the notification. Remember also to click the bell icon for notifications. Okay, so we have a claim here. Similar matrices have the same characteristic polynomial. So if you look at this claim here, we can see whether we can show a kind of a proof for this. So we are having two similar matrices having the same characteristic polynomial. So basically what we need to do is have A being similar to B. By that fact, from our previous tutorial, you will see that B can be expanded in this form, in form of A. And therefore, by the definition of characteristic polynomial, we are looking at characteristic polynomial of x being given by the determinant of xi minus b. Yes, polynomial, the polynomial characteristic of b in terms of x being given by that. So let's expand this. If you expand this, just introduce what you know, because we know b is this. Just substitute what you know, and you'll see that by distribution, this is true, same as this, because b inverse of p times p is direct to identity, so give you identity. Then distribute determinant, so you have that. We also have this times this. So if you look clear on this, you'll see that what we are having here is actually this, and this is actually the determinant for characteristic polynomial for A in terms of x. What does this tell us? It tells us that A is similar to B, and that's the end of the proof. So to this juncture, kindly subscribe and remember to share with your friends.